Now let us move on to the first question in the exercise. The question is, without actually performing the long division, state whether the following rational numbers will have a terminating decimal expansion or a non-terminating repeating decimal expansion. So now let's move on to the solution. We consider the first rational number given, that is 13 upon 3125. So to state whether the given rational number has a terminating decimal expansion or a non-terminating repeating decimal expansion, first we shall write the denominator as a product of its prime factors. Therefore, we shall factorize the given denominator, that is 3125. This can be written as 5 times of 625, and 625 can be written as 5 times of 125. 125 can be written as 5 times of 25, and 25 can be written as 5 times of 5. Therefore, 3125 can be expressed as 5 multiplied by itself 5 times. Therefore, 3125 can be written as 5 power 5. Therefore, the factors of 3125 are of the form 2 power m and 5 power n, where m is equal to 0 and n is equal to 5 in this case. Therefore, the given rational number has terminating decimal expansion. Now we shall move on to the second bit in the question. So let's go to the solution. Now we need to find whether the decimal expansion for the given rational number 17 upon 8 is terminating decimal expansion or a non-terminating repeating decimal expansion. So to find whether the decimal expansion is terminating or non-terminating repeating, we shall first write the denominator given as a product of its prime factors. Therefore, we shall factorize the denominator 8. 8 can be written as 2 times 4 and 4 can be written as 2 times 2. Therefore, 8 can be expressed as 2 times 2 times 2, which implies 8 is equal to 2 power 3 times 1, which implies 8 is equal to 2 power 3 times 1 can be written as 5 power 0. Therefore, the prime factors for 8 are of the form 2 power m times 5 power n, where m is equal to 3 and n is equal to 0 in this case. Therefore, the decimal expansion for the given rational number is terminating. Now let us move on to the third bit given in the question. So here we need to find whether the given rational number 64 upon 445 has a terminating decimal expansion or a non-terminating repeating decimal expansion. To find whether the decimal expansion is terminating or non-terminating repeating, we shall first write the given denominator as a product of its prime factors. Therefore, we shall first factorize 455. 455 can be written as 5 times 91 and 91 can be written as 7 times 13. Therefore, 455 can be expressed as 5 times 7 times 13. Therefore, the factors of 455 are not of the form 2 power m times 5 power n, where m and n are natural numbers. Therefore, the given rational number 64 upon 455 has a non-terminating repeating decimal expansion. Let us move on to the 8th bit of the question. So the given rational number is 6 upon 15. Here we need to check whether the given rational number has terminating decimal expansion or a non-terminating repeating decimal expansion. For that, first we shall simplify the given rational number. Since 6 and 15 are multiples of 3, so we have 6 by 15 is equal to 2 by 5. Now in the obtained rational number, that is 2 by 5, the denominator 5 is a prime number. Therefore, 5 can be written as 5 times 1, which implies 5 is equal to 5 power 1 times 1 can be written as 2 power 0. Therefore, the factors of the denominator are of the form 2 power m times 5 power n, where m is equal to 0, n is equal to 1. Therefore, the given rational number 6 by 15 has terminating decimal expansion. Now let us move on to the second question. The question is, write down the decimal expansions of those rational numbers in question 1 above which have terminating decimal expansions. So let us take the first rational number, that is 13 upon 3125. It has a terminating decimal expansion as solved in the first question. So now we shall find its decimal expansion. So let's move to the solution. To find the decimal expansion of 13 upon 3125, we shall first write the denominator, that is 3125, as a product of its prime factors. Therefore, 3125 can be written as 5 times 625, and 625 can be written as 5 times 125. 125 can be written as 5 times 25, and 25 can be written as 5 times 5. Therefore, 3125 can be written as 5 multiplied with itself 5 times. Therefore, the given rational number becomes 13 upon 5 power 5. Now, we shall multiply the given rational number with 2 power 5 on both the numerator and denominator. Therefore, 13 upon 5 power 5 multiplied by 2 power 5 by 2 power 5. This gives 13 times 2 power 5 upon 5 power 5 times 2 power 5. This implies 13 times 2 power 5 is 32 divided by 5 times 2 is 10. So 10 whole power 5, which is 13 times 32 is 416 by 10 power 5. So in the denominator of the obtained rational number, we have 5 zeros. Therefore, we shift the decimal point towards the left to 5 places. Therefore, we have the decimal expansion as 0.00416. Hence, the decimal expansion for the given rational number 13 upon 3125 is 0.00416. Now let us move on to the second rational number that has terminating decimal expansion. So the rational number is 17 upon 8. To find its decimal expansion, first we shall write the denominator of the given rational number as a product of its prime factors. Therefore, 8 can be written as 2 times 4 and 4 can be written as 2 times 2. Therefore, 8 can be expressed as 2 times 2 times 2, which is equal to 2 cube. Therefore, the given rational number becomes 17 upon 2 cube. Now, we shall multiply the obtained rational number with 5 cube on both the numerator and denominator. Therefore, 17 upon 2 cube times 5 cube by 5 cube. This gives 17 times 5 cube upon 2 cube times 5 cube. This implies 17 times 5 cube is 125 upon 2 times 5 is 10, so 10 whole cube. Therefore 17 times 125 is 2125 upon 10 cube, that is 1000. Since in the denominator we have 3 zeros, we shift the decimal point towards left to 3 places. Therefore the decimal expansion is 2.125. Therefore the decimal expansion for the rational number 17 upon 8 is equal to 2.125. Now let us move on to the next rational number that has the terminating decimal expansion. So the rational number is 15 upon 1600. So to obtain its decimal expansion, first we need to write its denominator as a product of its prime factors. Therefore 1600 can be written as 2 times 800 and 800 can be written as 2 times 400. 400 is written as 2 times 200. 200 is written as 2 times 100 and 100 is written as 2 times 50. 50 is written as 2 times 25 and 25 is written as 5 times 5. Therefore 1600 can be written as 2 multiplied with itself 6 times and 5 multiplied with itself 2 times. Therefore 1600 can be written as 2 power 6 times 5 square. Therefore the rational number becomes 15 upon 2 power 6 times 5 square. Now to obtain its decimal expansion, we need to multiply the given rational number with 5 power 4 on both the numerator and denominator. So 15 upon 2 power 6 times 5 square multiplied with 5 power 4 by 5 power 4. So from this we have 15 times 5 power 4 by 2 power 6 times 5 square times 5 power 4 gives 5 power 6. This implies 15 times 5 power 4 is 625 by 2 times 5 is 10, so 10 power 6, which is equal to 15 times 625 is 9375 divided by 10 power 6. Since in the denominator we have 6 zeros, so we shift the decimal point towards left to 6 places. Therefore the decimal expansion is 0.009375. Therefore the decimal expansion for the rational number 15 upon 1600 is equal to 0.009375. Now let us move on to the next rational number that has the terminating decimal expansion. So now we need to find the decimal expansion for the rational number 23 upon 2 cube times 5 square. Since the denominator is already in the form of a product of prime factors, now to find the decimal expansion, we need to multiply the given rational number with 5 on both the numerator and denominator. So now we get 23 times 5 upon 2 cube times 5 square times 5. 23 times 5 is 115 by 5 square times 5 is 5 cube, that is 2 cube times 5 cube. This implies 115 by 2 cube times 5 cube is 10 whole cube. Since in the denominator we have 3 zeros, so we shift the decimal point to left to 3 places. Therefore we have 115 by 1000. This gives 0.115. Therefore, the decimal expansion for 23 upon 2 cube times 5 square is 0.115. Now let us move on to the next rational number that has terminating decimal expansion. So the rational number is 6 upon 15. So the rational number can be simplified as 6 and 15 are multiples of 3. Therefore 6 by 15 can also be written as 2 by 5. To obtain the decimal expansion for 2 by 5, we need to multiply the rational number obtained with 2 on both the numerator and denominator. Therefore, we get 2 times 2 upon 5 times 2. This implies 2 times 2 is 4 by 5 times 2 is 10. Since in the denominator we have only 1 0, we need to place the decimal point towards left to 1 place. Therefore, the decimal expansion for 2 by 5 is equal to 0.4. Therefore, the decimal expansion of 6 upon 15 is 0.4. Now let us move on to the next rational number that has terminating decimal expansion. So the rational number is 35 upon 50. To find its decimal expansion, first we need to write the denominator, that is 50, as a product of its prime factors. Therefore 50 can be written as 2 times 25 and 25 is written as 5 times 5. Therefore 50 can be expressed as 2 times 5 times 5, that is 2 times 5 square. Therefore the given rational number becomes 35 upon 2 times 5 square. Now to obtain its decimal expansion, we need to multiply the obtained rational number with 2 on both the numerator and denominator. So now we have the numerator as 35 times 2 by 2 times 2 is 2 square and 2 square times 5 square, which implies 35 times 2 is 70 by 2 times 5 is 10 and it is 10 whole square. Since in the denominator we have 2 zeros, so we shift the decimal point to 3 places towards left. Therefore the decimal expansion is 0.70, that is equal to 0.7. Therefore the decimal expansion for the rational number 35 upon 50 is equal to 0.7.